Hello students, today we are going to see a new topic that is called as a pulley system. It is usually also called as a etude machine. Okay, so in this type of pulley system, they will ask you to calculate the acceleration of the system. Second thing, they will ask you to calculate the tension which is developed in the string. Third, they will ask you to calculate the tension developed at the pulley here. Okay, so three things we are going to study: how to calculate them, how we can calculate them by easy method, or by we call it as a tricks. Okay, first we are going to discuss the convention method to calculate the things. Okay, second thing, we are going how to calculate them by the tricks. Okay, so let's start. First we'll start for the acceleration of the system. Okay, so generally look here in the question they have given us that the m2 is greater than m1. Okay students, they already mentioned as m2 is greater than m1. So as you know that if the m2 is greater, as I'm saying m2 is greater than m1, m2 is greater, definitely its weight will be more as compared to this. So this body will try to move downward and this body will try to move upward. Are you getting that what I'm saying? Its weight is greater now, so it will move downward and it will move upward. Okay, so if this body is moving downward, this body is moving upward, the acceleration for this body will be in a downward direction. Is it right? Okay, and for this body the acceleration will be in the upward direction. Is it correct? Are you getting that? Because it is moving downward, it is moving upward. Now remember, both will have the same acceleration. They don't have the different acceleration because we have considered the pulley as a frictionless, and there is no friction in a pulley. That's why the acceleration will remain same. Try to understand the thing. Okay, so now look here, to calculate this acceleration we are going with the basic formula that is called as a Newton's second law of motion, that is F is equal to ma. Okay, so first we'll draw the free body diagram for this body. Okay, look here, you have your mass m2, so its weight will be acting downward, that is m2g, and its tension will be upward, t. Are you getting this? Okay, now as the acceleration is acting downward, you will get the acceleration in a downward direction. Okay, as the weight will applied in a downward direction, the tension will be in a upward direction. Are you getting this? Is it clear? Now if you have applied the Newton's second law of motion, F is equal to ma. Now students, tell me how many forces are acting on a body. Can you see here? There are only two forces. First is weight in a downward direction and other is tension in a upward direction. Okay, and acceleration is a downward direction. So the weight value will be greater as compared to the tension. You know this, we have already seen in Newton's second law of motion that if the acceleration is a downward direction, it means the weight will be greater as compared to the tension. So can I write here m2g minus t is equal to m2a? Is it right? Any problem for you in this equation? I hope no. Okay, now we'll come to the next point, that we have another body which is having the mass m1. Okay, definitely no doubt about that, the weight is going to act downward only. Okay, so no need to take tension, and the tension in the string will going to act upward. That is clear. You can see here, tension always acts away from the body, so tension will be in upward direction. Now the thing we have to see here, this body is moving downward, so its acceleration in a downward direction. Okay, and this body is moving upward, so its acceleration will be in a upward direction. Okay, is it right? So we have drawn the free body diagram for this. The next thing we are going to use is F is equal to ma, our Newton's second law of motion. Okay, now tell me, you can see, you can compare both the things. They are in front of you only. Which force will be greater in this equation? Definitely the tension is going to be greater, because the acceleration is the downward of, acceleration is in the direction of the tension. Okay, are you getting this? So can I say tension minus m1g is equal to m1a? You can call it as equation number second. Is it clear? So both the things are in front of you. Can you see this? Okay, very good. Now what we'll do, I will just write down this equation here. Okay, or just look here, t minus m1g is equal to m1a. This is your equation number 1, and I will write down equation number 2 like this: m2g minus t is equal to m2a, equation number 2. Okay, so t and t can get cancelled. Are you getting that? And if you add this, it will get m2g minus m1g is equal to, you can see we can take the acceleration common from here and you will get m1 plus m2. Is it okay for you? Okay, so now look here, what we are getting the value for acceleration, I will write down just here. You can just pay attention. You are getting m2g minus m1g, right, upon m1 plus m2 is equal to a. Have you got the value of acceleration? Is it clear to you? Any problem? Okay. Okay, now look here students, is it clear? Have you got the idea? We have taken this from this, we have got this equation, we have got this equation, we have just made the simple calculation format, and we have got the value for acceleration like this. Any doubt about this? Now we are going to see how to calculate the tension. Okay, the next thing is very important, how to calculate the tension developed in the string. Okay, now look at second question. The student will be in a problem that says the tension at both the ends will remain same. Yes, definitely, because we are using a single string here, we are not changing the string. Okay, suppose if the string here is different, string here is a different, the tension will change. Okay, so the tension is also again going to remain same. So now what we can do to calculate the tension, it is a very simple trick. You can use any equation. If you want this equation, if you can want any equation, you just substitute the value of acceleration in that equation. Okay, so let's try. Okay, so I have the equation for this, that is T minus m1g is equal to m1a. Okay, we are doing this to calculate the tension in the string. So can I do T is equal to m1g plus m1a? Just I have shifted here, it's very simple. Okay, so T is equal to, can you students, can you do like this, can you take the m1 common from that? Yes, it's so possible. G plus a. Okay, up till this the point is clear to you? Okay, I hope you have understood that thing. Now what you have got the value of acceleration here, something like that. So can you substitute this value in this equation? Yes. So T is equal to m1. Look here carefully what I do here. I will keep the g as it is. I will just substitute the value of, we have that is a m2g minus m1g upon m1 plus m2. Yes, are you getting this? Now listen here carefully and just pay attention here. You can see that g and g is there. Can I take this g common from here? And from here can I take the g? Let us consider. I will do this step only, so it will not create a confusion. M1 g plus g. Is it clear now? M2 minus m1 upon m1 and m2. Now it is clear to you? Now we will take the g common from that. So it will look somewhat like this. Just pay attention. T as it is, you will get m1g common from that. I have just taken the g common. So what will remain here? It will remain 1 plus m2 minus m1, m1 plus m2. Is it right? So T is equal to, you can see m1g. I will just shift this value here. Okay, how it will look? m1 m2 plus m2 minus m1 upon m1 and m2. Correct? So this m1 and m1 will get cancelled. So what you are getting from here is m1g. This m2 and m2, it will become 2m2 upon m1 plus m2. So tension you are getting 2m1 m2 g upon m1 plus m2. So we got the value of tension.